Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies. In this latest ChassisSim video tutorial, what I'd like to do in this tutorial is to take things back a little bit and really just to sort of re-emphasize some of the things that I've spoken about in earlier video tutorials. And really, the whole point of this tutorial is the point of this tutorial is what I would entitle the ChassisSim process, how to go through and connect the dots. Now, one of the things about ChassisSim is that for those of you who've watched the other ChassisSim video tutorials, by now an awful lot of you would probably get the fact that ChassisSim is actually a pretty powerful piece of software that can really help you get on top of your race car. But I also realized that for a lot of people looking for ChassisSim at the first time, they would look at something like this and go, oh my God, where do I start? Well, this is what we're going to discuss in this tutorial. And believe it or not, to get going is not as difficult as you think. The key to getting going with ChassisSim, as I've said on the ChassisSim Quick Start guides, and as I've said in a number of earlier tutorials, there are no brownie points for being a hero. The key to starting with ChassisSim is you start simple and then you get cute later. If you try and go too complicated too soon, you will wind up by confusing the hell out of yourself. So, where we start with ChassisSim, we need two very key points. First things first, we need a vehicle setup. And this is an example of a setup that I have from some pretty old legacy data for a Formula 3 car. So obviously we need things like spring rates, dampers, what our motion ratios are, our bar rate, what the suspension geometry looks like, the ride heights, cambers, etc., etc. So what we do is our first step is that we go through and we select on our car template and we go through and we select the template that most closely resembles your car. Now, this is a twin-shock Formula 3 car, so I'm going to select the Dallara F310 template and click on OK. Now, what I do is I now get a file save as, and what I'm going to do is I'm going to go to my ChassisSim Technologies folder. I'm going to go to my models folder, and I've set up a Formula 3 folder, and I'm just going to overwrite this example here called F309 Zandvoort example, and I'll click on save. Yep, click on yes, I want to overwrite that file, and I'm done. Now, all I now have to do is I'll now go through, I'll minimize the ChassisSim screen, I'll have my setup sheet, and I just go through and I can use either the tree structure here, or I can use the car graphic to go through and enter my setup. So you'll see here I've got springs as a 900-pound force-inch spring. So what I'll do, just to make my life a little bit easier, I'll select units to use. I'll select my units as pounds force per inch. And I'll now go through and start editing. My front spring is a 900-pound force spring. My rear spring is a 700-pound force spring. So I'll select 700, click on OK. Now I'll go through and look at my bar rates, and you'll notice in my setup sheet I've got my bar rate specified as newtons per millimeter. That's not a drama to deal with. I'll just go View, select units to use, go back to newtons per millimeter, click on OK, go through, and now I'll enter in my units to my roll bar rate, and click on OK. And what I'm going to be doing is I'll be saving as I go. It's as simple as that. So we're just making small changes every bit that we go. So that's the first part of the process. The second part of the process is obviously we need a monster file. Now, I cannot emphasize enough, a good monster file is next to godliness, and that contains dampers, accelerations, RPM, speed, steering, and throttle. Now, I'm not going to go through and show you how to create a monster file. You'll see actually a video tutorial where I go into that in great detail. But you'll see here that I've got my monster file good to go. And just again, to reiterate what that thing looks like, it's simply an ASCII text tab delimited file. That's distance, RPM, lateral G, longitudinal G, my 4 damper displacements, front left, front right, rear left, rear right, steer, throttle and speed. For those of you who are on monoshocks, what I would do is I would simply take from your data your front your front monoshock damper position and fill it into both columns. Don't worry, ChassisSim is set up to recognize the difference. That's something you don't need to worry about. So now that I've got my monster file, what I now need to do is my next step is now that I've entered in my setup, and now that I've got my monster file, and now that I've entered in my setup, what I now need to do is to go through and take my initial guesses of what the arrow looks like and what the tile looks like. So to do that, I'll go over here to initial model refinement. So my first step is I run the one-touch arrow modeling. I'll click here to import my monster file. It'll say my files are processed. I'll click here to run the one-touch arrow modeling. I'll click here to make sure that because my dampers were zeroed on zeroed on the deck, I click on OK, and now it's going to go through and it's going to do its thing. Now, at this point, you go away and you get a coffee, you get a drink, or you go outside and enjoy some fresh air. Now, I should add, this does not replace the ChassisSim Arrow Modeling Toolbox, but what it's designed to do is to take a set of data and to get a first cut approximation of an arrow map. Is it perfect? No, it isn't. However, just remember, our goal here is to get going, and this is what the one-touch arrow modeling is going to do. Now, to save some time, I'm just going to click here to terminate the calculation to show you what the end results are going to look like. Now, you'll see here the one-touch arrow modeling is done, and you'll be prompted to commit. Press the OK tab. So I'll click on OK to commit that. I'm not going to do it for this particular example because I've done it previously, but to apply that, you just click on OK. Our next step, now that we've got our arrow, and I should add that once you've done your one-touch arrow, you'll see that the arrow map is going to be filled out appropriately for you. Now, our next step is to run the tile force estimation. So I'll click here to add my monster import file. And what I'm going to do is click here to run the tile force optimization. I've got to fill in basically what my signs of my arrow optimizations are. So basically, sign of my lateral G in this case, a positive G was for a left-hand turn, so we put in -1. My dampers have been zeroed on the deck. I just now, to run the tire force estimation, I click on OK. And now it's going to go through and run the tire force estimation. So once again, you go off, get a cup of coffee, take a bit of a break. And then when it's done, you're going to have a result that looks like this, and we just click on cancel. Now, what this will do is that in the directory that you have saved your car file in, you'll see a file called optimum front tire force file and optimum rear tire force file. So to import that, all that you've got to do is click on the front tire, go import v3 ASCII tire file, click on optimum front tire file. I like for a quick sanity check just to see basically the result that it's done there, and I just click on cancel. And now to commit that change, I would click on OK. As I said, I've done this before and I don't need to worry about doing it again. So I'll just go cancel for the time being, but to commit that result, we click on OK. And for the rears, we go import v3 ASCII tire force results, click on optimum rear tire force file, click on open, and to commit that change, I'd click on OK. I'm not going to worry about that for the time being, so I click on cancel. When I'm done, I go to file save. Guess what, folks? You've just created the first cut of your car model. And now, all you need to worry about is generating a circuit model. So to generate the circuit model, we go to our tree structure and you work your way through the list. So we create a curvature file. So I'll click on my raw curvature file. I'll import my raw curvature file. I'll click here if I'm using a monster import file. I'll change that sampling frequency to 50 Hertz. To keep it really basic, I'm going to use a moving average filter set at about 0.5 of a second. This will basically pretty much cover you for really, really bad information. And then I click on my output curvature file, and you'll see here that I've got track Zandvoort 3 that I've already generated, and I'd click on open, and then to generate the circuit, all I've got to do is click on OK. Now, I've already done this before, so I don't need to worry about it right now, but I would just click on OK to apply that. Then, to create a bump profile, we simply click on here, to add my monster import file. And we click on create bump profile. Now we go through set up a few basic settings here. I'll set my droops, my maximum bump and droop clips to about 30 because this is an open wheeler. I'm going to set my filter to about 0.2 of a meter per second. That's a rough rule of thumb for an open wheeler. Touring cars are about 0.3 of a meter per second. And I'm going to click on allow auto bump scaling, and I'll make sure that my sign on my lateral acceleration is set appropriately to what the G is. I click on OK, and that will go through, and that will generate the bump profile for me. Now, I've already done that, so I don't need to worry about doing it. I don't need to worry about doing it again. Now, if I'm running on a circuit with significant altitude and road camber variation, I just simply click on altitude road camber variation. I click here for my monster import file. I make sure that my dampers have been zeroed on the ground. I load in the curvature file. I load in my bump profile, and the bump profile is of star.dat. And so I go through to my bump profile, Zandvoort F3, and you'll see here that my sign on my lateral acceleration has been applied. I click here to run the altitude road camber. I choose basically where I want my altitude road camber file to go, and all I've got to do to generate this is click on OK, and it's done. Simple as that. Now, at this point, you're pretty much done now with your circuit file. So to run this up, all you've got to do is go to enter a circuit model, or go to circuit data, and we click on our curvature file. And you'll see here, this is basically pretty much, this has been loaded from when we ran the altitude road camber file before, but I'll just load it through here for you. Star.dat, and here's my bump profile. I'll now import my altitude road camber file. And so that was my altitude road camber file. Click on use altitude road camber file. Click on OK. Guess what? You're now ready to run your circuit model for the first time. So typically what I do is I will run my circuit model, and then I'll take a quick look at the overlay. Now, if I've got corner discrepancies greater than about, say, 10k an hour, I will then go to run the auto grip matching. So I'll run my auto grip file. I'll import my monster file. I'll click on where I want my desired grip factor file to be. So I'll just call this grip factor Zandvoort demo. Click on OK. I'm going to say I'm going to use bumps and use altitude camber. Click on OK, and that will generate your grip factor file for you. And then to import that, now I didn't execute that because I've done this before. I click on import grip factor file, and here's my grip factor Zandvoort file. I'll click on OK, and we're done. Guess what, ladies and gentlemen? You now have a car file and a circuit file that you can now start doing some pretty good first cut analysis. Is it the complete story? No. However, what we have just walked you through is a very simple process to go from a blank sheet of paper to something you can start using in the space of little under an hour. So if you follow this process, you've got a first cut model that you can start to get some rough ideas in terms of where to go with spring rates, what to do with damper, geometry changes, and various other things that you can start looking at straight away. Is this the perfect car file? Does it replace going through and doing a correct tire force modeling procedure or doing a correct aero modeling procedure? No, it doesn't. However, what this process is absolute gold for is going through and taking a pretty good rough cut to see, okay, this is where we're at, and we can start throwing some springs and bars to see, okay, is this a rough direction we should be going in? But more importantly, it also builds a really good basis for you to go through and use the more advanced features of ChassisSim to do your aero modeling and to do your tire force modeling. But look, don't take my word for it. Go to the ChassisSim website, register for ChassisSim Professional online, buy a few credits, give this a go for yourself, and go through, work through those quick start guides, and you'll see for yourself what a powerful tool ChassisSim is. And if you work through this procedure, you can get running in next to no time.